Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Welcome back to this lesson series program. Teacher Patrick, I'll be with you today again, and I welcome you again, once again, and I'm very privileged once again to be with you in this lesson. I will be with the senior 6 chemistry class. And we are still talking about benzene and its derivatives. I hope it has not been boring because it has almost taken a long time. Our lesson today will be talking about the nomenclature, the acidity, and the preparation of the aromatic carboxylic acids. Nomenclature, acidity, and preparation methods of carboxylic acids. So when we're talking about the carboxylic acids, please, we are referring to the aromatic ones, the one that contains the benzene ring. What are we expected to do? Please, I hope you are ready, you are with me. You, by the end of this lesson, you are expected to do this, or you are expected to have understood this. 1, you'll be able to write and name some aromatic carboxylic acids. 2, you'll have to explain and write some methods of preparing carboxylic acids. I'm just referring to the reactions and equations. And 3, you'll be able to describe the acidity of the carboxylic acids and the effect of the substituents. So those are the 3 important parts that you need to understand as we move along with the lesson in these carboxylic acids, which are aromatic. So when we talk about the aromatic carboxylic acids, we are talking about the carboxylic acids that contain a carboxylic group that is attached on the benzene ring. So we have, this is the benzene ring. Remember, when we talk about the benzene, this is very important. Remember to put that ring, because that's what makes it benzene. So we have basically, that is the simple compound of the aromatic carboxylic acids, which is benzoic acid. So this is the simple benzoic acid. So this is one of the simplest. So we have 2 forms of these carboxylic acids that we are talking about. Either we'll have this substituent attached on the benzene. That is one. So this is the carboxylic group is attached on the benzene directly. And then we are having other forms of these aromatic carboxylic acids. For example, where you have the benzene ring, for example, this is CH2COH. This is a benzene, or this is the benzene, but this benzene is not attached on this carbon that contains this group, the carboxylic group. So what are we supposed to do? How are we differentiating? I said now 2 forms. 1, where the carboxylic acid is attached on the benzene directly, and 2, you may have some other forms where the carboxylic group is not attached on the benzene ring. So that means this benzene ring is a substituent of this carboxylic group. So this one will be named as 2 the phenyl. So the phenyl group is on the carbon number 2. So this is 2 phenyl benzene carboxylic acid. 2-phenyl benzene carboxylic acid. So you need to remember to put the word carboxylic acid. We may have, whether it can also be either one group that is attached on the benzene ring, that is, I'm referring to the carboxylic group. It can be attached on the benzene directly, or it can be even more than one. Or you may have this, whereby you have one carboxylic group And then you have another one. This is another carboxylic. So these are two carboxylic groups that are attached on the benzene ring directly. So this is 1,2 or benzene 1,2 dicarboxylic acid. So this is named as benzene 1,2 dicarboxylic acid. Much as you may have some of the aromatic compound, the aromatic carboxylic acids, you may have this compound, CCOH, and then you may have also CCOH. So this is H, and this is H. So this is a dicarboxylic, but this is an aliphatic compound. So we can also as well write it in this form. You have two carbon atoms with, this is OH, and then I think this hydrogen is not there because the bonds would be many. So this is OH. So this is ethane 1,2 dicarboxylic acid. Ethane 1,2 this is ethane 1,2 dioic acid. This is dioic acid, sorry. Ethane 1,2 dioic. Di because there are two groups. This is the carboxylic group. This is another group. So this is the same as this one. So with those are some others. So we may be having this. Another one, we may have this, for example. If you have CH2, COOH. So this is a propanoic acid. This is a propanoic acid. So this one would be 1, 2, 3. So this one would be 3-phenyl. 3-phenyl. So we have the phenyl group attached on carbon number 3 of this propanoic acid. Propanoic acid. 3-phenyl propanoic acid. Hey, I think I have to make correction here once again. Some bit of correction. So the phenyl, so this is ethanoic acid. So we have already mentioned the phenyl. So this benzene carboxylic acid can even be removed. So that is, we can call this one. This is phenyl ethanoic acid. Phenyl ethanoic acid. Why? This is the ethanoic acid, because it is not attached directly, this carboxylic acid is not attached directly on this benzene. So it has two carbon atoms. So that is how we can name. If it is directly substituted, or we may have some other compound. For example, you may have some other substituents. This is a benzoic acid. But then you may have another, either it is a nitro group or a methyl group, or you may have something like this, COH, this is a methyl group, or you may have this. We may have this benzene, then you have either bromine or chlorine, and so on. So what is happening? This is the nitro group. So that means it is 2 nitro. This one takes position number 1. So this is position number 1. So that is why we call this one 2-nitro benzoic acid. 2-nitro benzoic acid. 2-nitro benzoic acid. So it means this is a substituent of the benzoic acid. So this is 2-bromo benzoic acid. Benzoic acid. And this one, what would be the name of this? This is a methyl group attached on carbon number 2. So this one would be 2-methyl benzoic acid. Right? Or you may have even some other, if you have some other substituents, then just indicate the positions of those substituents. So that is how we can name these carboxylic acids. These are some of the structures we are talking about. I've just even given some of the example. You have this is 4-methyl benzene carboxylic acid or benzoic acid, as you can name it, or you can have 2-methyl benzene carboxylic acid. So it depends on the substituent that is indicated. You may probably have some other substituents. For example, if you have, maybe you have a bromine, and then you have a chlorine. So these are different substituents. What you do, you remember, you recall the alphabetical order of these substances. So which one comes first? The bromine, the chlorine. In the alphabetical order, B comes before C. So that means in your naming, you have to start with 2-bromo. Remember, if it is a bromine, then it is named as bromo. If it is chlorine, it is named as chloro. So this is 2-bromo, 4-chloro, 4-chloro, benzoic acid. Benzoic acid. So that is the name of that compound. You may have other substitutes, a methyl group attached there. You may have a methyl group, or maybe this is, you have a methyl group over here, and you have a bromine also attached. This is also, it is named. It will be, all these are substituents. This one still is a benzoic acid, right? So how do you name this compound, for example? So as we have named this, still you'll need to locate the positions of the methyl group and bromine. Remember the alphabetical order of these substances. 1, the bromine and methyl. So bromine comes, B comes before M in the alphabetical order. So this one will be 4-bromo, 2-methyl, 2-methyl benzoic acid. Benzoic acid. Or benzene carboxylic acid. So when you don't need to use the word benzoic acid, you can still use the word benzene carboxylic acid, as we have seen. So these are some other examples that I've been giving. 2-phenyl ethanoic acid, I've mentioned about that one. 2-phenyl propanoic acid. This is 2,4-bromo benzoic acid. 4-nitrobenzoic acid, benzene 1,2-dicarboxylic acid. It is commonly known as butyric acid. So these are some of the examples I was just even talking about, so we don't need to just repeat them. So let's move on straight to the preparation methods. Preparation methods. So we talked, if you remember, carboxylic acids that you talked about in Senior 5, the same methods are used, but there are some few differences that can happen. Mainly, the first method, because we have talked about this one, when we are talking about the reactions of the benzene and methyl benzene, this reaction has been coming repeatedly, coming again. So oxidation of the alkyl benzene will take you to the methyl, will take you to the benzoic acid. So there is something very important thing that I just want to mention. Please take note of this. So we may have this, you may have methyl group. You may have whatever alkyl group that you may have here, C2CH3, or you may have this. Say this is CH3, and you may have hydrogen over there. And again, you may have another compound similar to this. This is CH3, this is H3C, H3C. So here, look at these compounds. Look at the alkyl groups that we are mentioning here. This is something I just want you to note. This alkyl group here, this is an alkyl group. This is a secondary alkyl group, isopropyl. This is another alkyl group, and this. this one, and this one can all be oxidized to this compound, benzoic acid. Can all be oxidized into benzoic acid. Or this one. Under favorable conditions and the reagents that can be used, the oxidizing agents. This one will be oxidized, this one will be oxidized to this one will be oxidized to this. This one won't be oxidized. That is what I wanted to emphasize. Why? When we are talking about oxidation, the oxidation is the addition of the oxygen, remember, or it is the removal of hydrogen. This carbon here, which is a tertiary alkyl, this is a tertiary alkyl group. So this one doesn't contain a hydrogen. This one contains hydrogen, this one contains hydrogen, this one does contain hydrogen, but this one doesn't. So this one cannot be oxidized. So all these others can be oxidized because they contain a hydrogen atom. So there are some other oxidation reactions. Oxidation of alcohols. That is an alcohol over there, which is oxidized to an aldehyde. This is an aldehyde. Then to benzoic acid. Hydrolysis of nitrides. These are some of the reactions that we are repeating again because these methods are used in aliphatic carboxylic acids as well. Carbonation from Grignard reagents. This Friedel-Crafts, Charles Friedel and Mason Crafts. I talked about these reactions when we were talking about methylbenzene, and which is acylation or alkylation. So it is not something that is new. Or the hydrolysis of trichloromethyl groups. So by calcium hydroxide and boil, then elimination of water, then which changes into the carboxylic acids. So this is something that I wanted us to discuss once again. I hope you have taken down this one. So I have to remove this. On the acidity of the carboxylic acids, this will depend on the substituents, as we said. The effect of the substituents, carboxylic acids. For example, if it is benzene, when this compound, this is benzene or benzoic acid, so in the solution form, if this dissolves in the solution, so it will form this one will be then plus the hydroxonium ions. So this negative charge over there, this behaves as an acid because it can be able to eliminate like other weak organic acids. But we are talking about the effect of the substituents. How do the substituents affect this? For example, if you have a substituent that, for example, is donating the electrons to the ring. If the electrons are donated into the ring, and this is a carboxylic acid, what happens? So if the electron, this is electron withdrawing group. That is an abbreviation that is not standard. Electron withdrawing group, electron donating. We are starting with electron donating group. Entering here, what happens to this? So that means this one will destabilize the anion. And once the anion is destabilized, what does that mean? It means this one reduces the acidity. This one reduces the acidity. Reduces the acidity of the charge. Reduces the acidity of the carboxylic group, the whole compound. We are not talking about the charge. Reduces the acidity of the carboxylic group. So that means electrons are entering. What happens? If they are entering here, it means they are moving towards this oxygen. If I can just put it in this form, that is oxygen over here. That means the ability of the compound to behave as an acid depends on the easiness on how this hydrogen can break away. So in this case, when electrons are entering into the ring, that means they are moving out of the ring and they are coming towards this. So the bond between oxygen and hydrogen becomes stronger. So that ability to remove the hydrogen is reduced. That is what I'm talking about. If you have some other substituents, for example, the substituents we are talking about now, they withdraw the electrons. Electron withdrawing groups. I said this is not standard. I'm just using it for shortening it. Electron withdrawing group. Now here, the electrons are being withdrawn from the rings. Assuming you have, remember those groups that withdraw the electrons. Remember electron donating groups. The methyl groups, we have the OH groups, all those ones donate, assuming you have the OH here. Now, assuming here you have a nitro group, so it will be removing the electrons. That means this will, if the electrons, so that changes the direction, this bond weakens. As the bond becomes weaker, then the ability to release the proton goes high. So this one increases the acidity. What increases the acidity? Electron withdrawing groups. What reduces the acidity? Electron donating groups. So look at this. It is the same thing that happens over here. Compare the acidity of 2-chloroethanoic acid and ethanoic acid. That is an example that we are talking about. 2-chloroethanoic acid. So you have, this is 2-chloroethanoic acid. This is chlorine over here. This is hydrogen. This is 2-chloroethanoic acid. So you're comparing it with ethanoic acid. These two. This is ethanoic acid over here. What happens? This is electron withdrawing. So it has what we call the negative inductive effect. If you remember, negative inductive effect. Negative inductive effect. This methyl group donates the electrons towards this. So this one removes the electron from that carbon. That changes the direction here. So the electrons will be moving towards the chlorine because of its electronegativity. Therefore, because electrons are removed away from the hydrogen, that increases the acidity. Increases the acidity. What about here? Electrons are moving towards this hydrogen. This is positive inductive effect. Positive inductive effect. So these words actually are used interchangeably with electron withdrawing and electron donating. So it is just the words that have changed, but the method, the idea behind and how they affect the acidity is also the same. So positive, this reduces the acidity. The acidity. And remember, these are aliphatic carboxylic acid. So I was just trying to look at those compounds. This is what I was just talking about. How the electron withdrawing, electron donating affects the acidity of these carboxylic acids compared to the aliphatic carboxylic acids. So that is why I brought these ones over here. It is just, this is for the comparison. So the same effects, but when we are comparing here, remember we use these terms: negative inductive effect, positive inductive effects. And when we are looking at these ones, we are talking about the electron withdrawing groups and electron donating groups. So those are the some of the words that we use continuously. So you need to remember that. You need to remember that always. So there was another question there, which is part B over there. Compare the acidity of methanoic acid and ethanoic acid. Probably briefly I can just talk about that one. Methanoic acid, this is methanoic acid. Methanoic acid is written, this is the structure of the methanoic acid. And this, another one they're talking about ethanoic acid. So the ethanoic acid is this. So which one would you think is more stronger? Because they are all carboxylic acids. Remember these two words. This is, so the moment, if you can recall, the idea that you used, the idea the teacher explained in aliphatic carboxylic acids, then you'll be able also to explain the idea of the electron withdrawing groups and electron donating groups. So coming back to this one, because I never wanted to leave it behind, I've just asked it. So this is electron donating. So he said electron donating always reduces the acidity. This hydrogen is neither of the two. Doesn't reduce, it doesn't remove the electrons, doesn't withdraw the electrons, and it doesn't even donate the electrons. So it is neither has the positive or negative inductive effect. So in that sense, this is more stronger. This is more stronger than this one. So this is less stronger compared to these two. So as I wind up this lesson, and I will have to thank you so much for being with me. I hope we've been together. But I have to leave you an assignment. And over there on the screen, you'll see the assignment. I hope to see you in the next lesson when we meet again. Bye-bye.